this Samsung 60-inch LED power supply board, and this board here is totally dead, which means that at plug-in or standby there is no standby light on the TV. It's just as if the TV is unplugged. There's no light, there's no clicking, there's nothing. It's totally dead. So that could be an indication that it is the main board also, besides the power supply. The first thing I normally do in a dead TV set is check the AC fuse. This is just what I do, okay, before anybody starts nitpicking. You don't do that, but anyway. And I'm going to check the AC fuse, and that is the fuse that is always by the power supply cord plug-in, which is right here, okay. And there's always a fuse there. Whether it looks like this, it may be a smaller one, but there's always a fuse there. And sometimes in smaller TVs, they actually have it like hidden, like a little box thing, a little box fuse. But you'll always notice because it's always by the power connector, and it will be labeled F something in most cases. It will have the amperage, as you can see here, the amperage and the voltage of the fuse. So actually what I'll do is I actually put my meter and diode or resistance, it doesn't matter. If you hear the beep, then you know it's good. I want to make sure that's not open. Okay, that's what it should read if it's good, low ohms, or if I put the meter in the diode scale. We are in ohms right now. If I put the meter in the diode scale, or the beep, it doesn't matter. You'll have like this little symbol here for the beep. That's what it should sound like if it's good, okay? So I'll go across the fuse here. And as you can see, I have absolutely nothing. Okay, I put it on ohms. My meter's a little off, but it still says it's open. Okay, now if you have an open fuse in the AC circuit, or the line in fuse, and that's open, a lot of boards will have another fuse for the DC circuit, or the hot ground. I'm sorry, or the cold ground, like I said. And as you notice, all power supply boards, this is a switch mode power supply. That means that it uses a switching transformer to produce the voltage at the output stage, which goes to this plug here. That plug that's going in this connector is going to the main board, okay? And as you can see, there's a little legend next to it. But anyway, anytime you have a fuse in the AC circuit, okay, as you can see, this power supply is separated by a line. Usually on all power supply boards, switch mode power supply boards, it is separated with a line, and that's helpful for you because you can make correct measurements. So anytime you're measuring anything over here on this side of the line, which is most likely where the AC comes in at, you're going to have to use hot ground. Okay, the most common hot ground is the negative side of these big filter capacitors. Okay, anytime you're over here on this side, all of this is cold ground. Okay, so you can use anything that's ground on the board, or you can use these tabs here, right here, or you can use anything metal in the power supply. See, it is even labeled cold ground. Okay, so the fuse is open. So the first thing I'm going to do is check to make sure, to kind of isolate this and see if the problem is in the hot ground or cold ground, or if it's in the first stage of this power supply, in the AC stage. Okay, as you see, there's our rectifier right here. That's what rectifies the AC into DC, okay, and drives this transformer, and then the transformer in turn drives the rest of the power supply board and produces your standby voltage, which is DC, and the 13 volts for the audio and whatever, and so on and so on and so on. Okay, but anyway, the first thing I'm going to do to check that is I'm going to go to hot ground. As you can see, the negative side of these big filter capacitors is to my right. Okay, okay, your right hopefully too. And I'm going to go to the negative part here. I'm going to go put our meter on the beep so I can hear it. And we'll go to the fuse and make sure there is no short. Because if there is a short at the first stage here, okay, that means that most likely you have a bad, this is probably bad, or this is bad. But, however, I'm going to flip the board over and check these fets, this fet, and we're also going to check the bigger diodes. And I can almost guarantee you that we're going to find, or you are going to find, a short on one of these fets or one of the big diodes on this side of the circuit. Okay? Alright, so I'm going to turn this over. Okay? And see if we can zoom in here. And as you can see, I've already got something marked there in red. Okay? And these are the other two fets right here. Okay? So it didn't take me long to find out which one it was, but okay, it's reading. I got my meter in the diode scale and it's reading 0.512. Okay, so there's no short there. This next one, same thing. I'm checking across that one. Check across. Now these two may be shorted because of the circuit that it's in. I believe this is the gate and source, and this pin is a drain. So if you get something a read like that, if it's shorted, you know, that's just keep going, because it may be, it depends on the circuit, and it's going to the transformer also. But what you want to consider is the middle pin and one of these two leads. If the middle pin is reading short with this lead or that lead, then this transistor or MOSFET is shorted. Okay, now that was reading pretty good. I'm going to go over to the ones that I've got marked in red, which you already know are shorted. Why? Because I have them marked in red, that's why. Okay. Now that's reading low, a 0.111 in the diode scale, when it should read like either 500 or infinite, 0.500 or infinite. Okay, we have a short. That should not be shorted, okay? And I'll go to my next one here. And that is definitely shorted all the way around. Now, in a lot of cases, that is these two transistors right here. These two right here are shorted. Yeah, I'm sorry. These two right here. These two MOSFETs are shorted. And as you can see, it's in the hot ground section. So that's why the AC fuse blew. So it's on that side. So that's why it's shorted. It's really simple. Trust me. So the next thing you want to do is take the MOSFETs out. Now, in a lot of cases, they're both reading short in the circuit, but actually only one may be shorted. But you have to pull it out and find out. Okay, I'll just go ahead and place them both. But if you're like in a budget and you're in a hurry, right? As long as the other one's not shorted, you can probably get away with it. But I'm going to pull those out and find out what the part number is, and I'm going to show you guys how to match it up, because this is a TV power supply board. It's not a logic circuit. You can sub, but you have to know what to sub it with. You have to know the ratings and what you're in the what you're looking for as far as the voltage and as far as the wattage. So anyway, we'll pull those out. Okay, Before I forget, we're going to look at the part number of this power supply board, just in case that you need to replace the board. And the only reason that I would replace the board, for instance, is to make sure that you do not have any standby. You can also check the standby voltage with the board out of the circuit, as long as you be very careful not to touch the underside of the board while it's plugged in. Okay, make sure there's no metal on the bottom of it. Make sure it's like a surface like this. You know, don't lay it on any aluminum foil, or make sure there's no solder up under there, or a roll of solder, okay, before you turn it on. And like I said, precaution, disclaimer, whatever you want to call it, warning, when you're plugging in the board separate, make sure that you do not like grab it like this and turn it over, you know, while it's on. Make sure the board is either already turned over, then plug it in, or just leave it like this and make your checks, okay? But anyway, let's look for the part number on here. On any Samsung power supply, we want to look at this number. I'm going to show you exactly how to read this too, okay? This part number on this board is a BN44-00775A. Okay? That's how you get the exact part number off this barcode sticker, and that's how you read it. There probably is another one that's pre-printed on the board. Let me see here. Don't see anything. Oh, here it is right here. Okay, right at the top there. Okay. Right there, BN 44-00775A. Okay, so we got that out of the way. Now, I'm just going to mark that so I don't take out the wrong ones. Okay, those are the two MOSFETs that we're reading short. So the first thing I want to do is remove them and get the part number off of them, because it's covered in this glue-like substance, which actually is supposed to keep the interference down, as opposed to help on cooling it. So this is going to be like a tricky right here. You may have to make sure that you have some handy little tools here. I'm actually going to, because you have to get those little screws out, and actually this heatsink on the other side is kind of like in the way. So I'm just going to get like a small Phillips, and it's going to be on an angle, but these shouldn't be in very tight at all, okay? So I'm just going to unscrew it first. That's just how I do it, okay? Make sure you do not lose those screws, and make sure that you put those screws back in when you're putting in your new MOSFET, because that is what keeps the FET cool, because it's pushed up against this heatsink, okay? So I've seen a lot of technicians, I don't know why, they just lazy, they just put them in there and think that's going to hold up, but guess what? It's going to overheat eventually, okay? And there's also some heatsink compound on the back of each of the MOSFETs. Anyway, I want to pull the screws out, and we need to get this stuff off of here. That's really the only hard part. Make sure that you do not damage nothing, or pull or yank off one of these blue capacitors, okay? Because we don't have to get the whole thing off, just enough for us to loosen it up after we unsolder it, and it'll come out the circuit. So anyway, we'll just take something sharp like this. You can also use this, which may assist you, or some needle nose pliers. But usually how I do it, okay, I just use something sharp and scrape from the bottom. Kind of stick it on the bottom. And like I said, don't scrape it, but just kind of lift it up. It should lift right up. You see that? Make sure there's no cap in the way. Just kind of pry it loose a little bit first. really don't see the purpose of this. I actually think it's a way to tell if somebody's been working on the TV, if the TV is still in the warranty. But I've did several replaced MOSFETs, didn't put this back on, and you know, I haven't never had any callbacks on it. So it's pretty tricky. I have to work with it for a while. You have to just keep doing that. And that's pretty much about it. Just do that for both sides. Take your time. Okay, I got most of that little white stuff around there off. Like I said, I actually think that does more harm than good, because every time I get a Samsung board, it's always the fets that are shorted. Always have this white stuff on it. If anybody has any idea what that's really for, please let me know in the comments, okay? But I'm actually thinking that they're doing that on purpose, okay? Or they do not want you to, they know it's going to blow out, so that they don't want you to take it off. They figure they'll make it hard for you. But anyway, all I'm going to do now, okay, I took the screws out, of course. We put both the screws out. And I did just kind of wiggle them away from the board here. And I'm going to show you a little technique that I use to get these fets out pretty fast, is I don't use any solder suckers or whatever. Basically all I do is just, I usually get a tip like this here, and I'm actually going to put some solder on all sides. This just works a little bit easier for me. Make sure it's extra hot. And then what I'm going to do is just go to the other side, get some needle nose pliers, something like that. I'm actually going to grab it like that, okay? And I'll actually, once I do that, I'll actually, so I'll get this on camera. Probably not. Figure. But I'll just sort of heat each pin up and kind of wiggle it out. So see how easy that came out? Okay. I'm going to check this one first before I remove the other one. That's reading good. So this may actually be good. And the other one is probably shorted. Yep. That's good. So we'll just remove the other one the same way. Okay. So I put the other MOSFET out, and I'm going to check it. That one is definitely shorted. All the way around, okay? Okay. And just to double check to make sure there's no other problems, I'm actually going to go back to the trace where I took the MOSFETs out, and I'm going to double check and make sure that that is not shorted. On the trace, okay? Make sure that we don't have any further problems. No shorts. Okay, and no short there. Okay. Now, when I remove the transistor, when I remove the MOSFETs, another thing to double check are these capacitors. Make sure they aren't burnt. But quite naturally, I did find one. I don't know if you can see this or not, with the back blown out. Which way do I got this? Okay. Right here. You see that? Now, I did check it. There's no short there. A lot of times what happens is it will spark, and yes, the back will fly off. But as long as it's not shorted, it shouldn't do any damage. If you're unsure, just go ahead and replace it. All these other ones seem to have the same part number. So just try to find one like that. So I'm going to just take a chance and leave it in there because it's not shorted. It can't do any more harm than good if I do replace those fets and fire it up. So anyway, I did also check the transistor, the MOSFET that's behind it, and that is okay. That's actually a diode, okay, and that is reading okay. So let me get off track here. Yes, I checked this. This is a diode here. Only has 2 pins on it, and that seems to be okay. And another thing to remember is check resistors. If you have any shorted MOSFETs, check the resistor, like this resistor right here. Check that. Check any other transistors or anything around that. Make sure that's not shorted. But usually on a LED or LCD power supply, if you got a FET and the fuse is blown, it probably blew the fuse out before it gets anything else anyway, besides sparking that cap there. So that's a good sign that it's hopefully just the FETs. And so we're going to find the part number. Okay, as we can see, the part number on this particular FET is a 60R580P. Okay, and that's the same part number on both of those FETs. So the next thing I'm going to do is go online and check out the data sheet on this FET and check out the specs. Okay, so what I'm going to do, I'm just going to go to Google and just type in the part number. And what was that? 60R580. Okay, that already came up. As you can see, it says 60R580P MOSFET data sheet. We'll click that. We'll find one that says data sheet. I prefer to use all data sheet, but let's see what we got here. Here we go, right here. Okay. Any one of them is fine. What you want to see is the voltage. And we'll just click on one of these PDFs. These are pretty much all the same thing. I don't know what's the difference, but this is not really what I'm looking for here. For some reason, let's go to the. I want to get the. Okay, here we go. All right, cool. So the rating from drain to source voltage is approximately 600 volts. Okay, that's where the 60 comes in. Okay, that's really the only thing that really we're concerned about because, like I said, it's just probably using the driving the transformer. Okay, so and the other thing we want to look for is the current. Okay, the current, continuous drain current, 5 amps and 8 amps. Okay, and you can kind of configure these out because it says 60R580P. Okay, and basically what it's saying, it's a 600 volts, rated at 600 volts like we just seen. Okay, and there's a 0.58. That's the resistance that it uses to cut it on between the drain and the source. Okay, I believe, and there's also we've seen the continuous drain current between 5 and 8 amps. Depends on the temperature or the MOSFET right here. Okay, so if it's much cooler, it will produce 8 amps. Okay, now what I have actually is this is the only thing I have is a PF 11 and 660. Now these are much easier to read because I know it's an 11 amps, which is higher, and the 60 is also 600 volts, and it is a N channel. That's what the N stands for, the same as the other one. So we'll go ahead and look at it. And actually, this is an F on the end. I don't know if that makes much difference or not. Come on. We'll search it. Okay, let's check out the data sheet. Here we go, data sheet. Okay, 600 volts, 11 amps. And this is 0.38 ohms. The other one was 0.58. So that's like the only difference. It is an N channel drain current. Let's see, between 7 and 11 amps. Okay. So the other one between 8 and 5. So that's pretty close. As far as anything else in here, like I said, you're not using this in any medical equipment or any kind of space technology or robots or anything. So this other stuff is relatively useless pretty much, because all what this MOSFET is doing is just driving a transformer. That's it. Okay. And so we're going to try. I have 3. I'm going to try them both in there, and we'll see what happens. Replace the fuse, and then we'll see what happens. Okay. So these are my FCPF11N60F that I'm going to replace those with, and also replace the fuse if I can find one. But anyway, so like I said, basically when you're replacing MOSFETs in a TV power supply, the main thing that you're concerned with is the amperage. Okay, the current. Okay, so this old one, this is the 60R580P. The 60 stands for 600 volts. And the 58 is, I guess it stands for two things. One is the 0.58 turn on resistance to turn on the drain, I believe. I'm not sure. If anybody knows anything better, just leave a thing in the comments. I'm not an electrical engineer, but I know the voltage rating and the current. So at 25 degrees Celsius, this can produce 8 amps of current, and up to 100 degrees Celsius, go down to 5 amps. This one is 11, which is 11 amps. Okay, that's the maximum amperage at the coolest state, which is 25 degrees Celsius. And as it warms up and heats up in place for a while, the amperage goes down to approximately, I think it was 7. Okay, now I know I get somebody in the comments, you got to price the exact one. Well, replace the exact. Go on eBay and look up the part number, and I'm pretty sure you'll find it. You can go to DigiKey, Mouser, anywhere, or you can just look up the part number on the board to get the whole entire board. Okay, so I'm going to actually put these two in there. I'm also going to add some heatsink compound to the back of it, just like on the old one there. It was a little bit on there, just to make sure that it does stay cooler. But actually this is rated a little bit higher, so I'm pretty sure that will work as long as there's no other problems on the board. So we'll go ahead and try that, and we'll see what happens. Okay, so what I did is I just took these MOSFETs, bent the middle leg, just like on the original one. And then I also had to do a makeshift fuse. I just took because I didn't have one that I didn't have a pigtail fuse like this one. That's the old fuse that was blown out. So I just took a fuse. I think it's like an amp difference. No big deal, right? Don't go too high, because if there's any problems, if there's any other problems still on the power supply board, if you go too high, it's going to start burning some stuff up before the fuse blows again. So anyway, I just took a regular fuse and I just put some solder on each end and cut off a lead to a capacitor resistor. And just here, let me just another little trick that I do. If I don't have the pigtail fuse, I just take a regular fuse, put a dab of solder on each end, okay, and I just get some leads, like leads off a resistor or a capacitor, and just cut them and put them on each end, and that's it, okay. And I'm also going to put some heat sink compound on these new MOSFETs, okay. And I also have to take the solder off of the board here. Okay, I've already got one done, and I got this little cheap, I bought a little kit here with a solder sucker, and it's pretty easy because I already put some solder on there, remember, the first time, so that makes it a little easier. And I'm just going to heat this up. Hopefully you can see this on camera. Heat it up real good. See? Voila. Easy, right? Now the other hole's already completed. I'll go to the next one, and oops, that might work. Okay. Just like that. That easy. Okay? Okay, I got both my fets in, and I've also got my fuse in right there. Okay. Now, before you solder these MOSFETs in, you want to make sure that you can get these screws back in there, because you want it as tight as you can up against the heatsink. Not overly tight, but yeah, just tight enough where it's actually flush against the heatsink, because that's going to dissipate, dissipate. The MOSFETs are going to dissipate a lot of heat anyway, and so you want to make sure that it's it lasts longer. Okay, so it's going to. Okay, so what I usually do is I'll just take something like long and thin. This is a lead for my meter, and because I got the heat sink on there, and I'll just make sure that it is flush where it'll go all the way through. Okay, I can put my screw in there, and we'll do the other one. Okay, so it seems to be pretty good there, and I'll put my screw in. I'll just use my finger at first and just make sure that it is going in there. Yeah, because you don't want to solder it first, and then when you go put the screw in there, it's like uneven. Right, so, but anyway, you definitely get the picture on that one. Okay, I got my MOSFETs soldered in, and my fuse is soldered in. I put them in there, cut off the excess leads. Like I said, make sure you put the screws in first before you solder the MOSFETs, because I got into a bad habit some years ago. I kept doing that, and it was so frustrating, right? But anyway, so what I'm actually going to do is plug it in the board, and we're going to go over here to the cold side where your output stage is for your rectified voltage, and that's going to your main board here. And as you can see, there is a test point right here on this FET, on the secondary side, or the cold, on the cold side of the power supply board. And typically power supplies use 5 volts, but this particular Samsung uses, it tells you right here in standby, it should be at 8 volts. When you turn the TV set on, this pin right here should be at 13 volts. Okay, so we'll go ahead and check that. Okay. I'll get my meter to stand up. That'd be nice, right? And I'll go ahead and plug the TV in first. And I'm sorry, plug in the power supply first. Make sure that you don't have anything up under there. Double check. Make sure there's no solder, like this little piece right here. Nothing metal up under there at all. Okay. And I'm going to plug in the power cord to the AC. So good so far. I didn't see the fuse pop or anything, so it might be in good shape. And I'm actually going to ground this on. Just be careful when you're picking this up, okay? I've been shocked before, so really, so just so you know. But I'm just gonna just so I can show you, I'm gonna ground the ground right here on the secondary side. That is ground, okay? If the board was in the TV, you could just put your negative lead on chassis ground anywhere metal on the inside of the TV. And so let's get my meter in range. So you can see that I'm going to hold my negative onto the ground, and I'm going to carefully go here, make sure that you don't slip or and touch anything else in the lead. Just try to pinpoint it there. Look at my meter. As you can see, we are at 12 volts. Okay, my meter's a little off, so it's 13 volts. So the TV will, it's pretty much on now. So if I go ahead and plug, when I go back to the customer's house and I put the board in there, as soon as I plug it in, the TV's going to come on. Okay, so that's a good sign. So anyway, guys, thanks for watching. If you liked the video, make sure that you give me a thumbs up. Thank you for all my subscribers. Appreciate all you guys, the comments and good tips and stuff. And once again, Big Dog out.